So again, my name is Joe. I'm still the only Joe at H2O, so my email is joe@h2o.ai if you want to reach out to me. The Twitter handle for H2O is at H2OAI. So this is about one of the functions in our software called Driverless AI. So in this talk, I'll give you an overview of the company first, and then some of our platform, machine learning platforms, and then I will try to squeeze in a live demo at the end to give you a feeling of this software. So how many of you have heard of H2O before? Oh, great. Yeah. So we are still a young company, still a young startup in Silicon Valley. So we focus on machine learning platforms. We have about 120 people now around the world, mostly in US. We work on machine learning platforms. So we have the open source H2O machine learning platforms. We also have this software, is the commercial Driverless AI, which is the focus of today. The main office is in Mountain View, California. And we do have other office in London, in Prague, in India as well, a new one in India. So H2O, we work on like a generic machine learning platform. So as long as you can frame your business problem into machine learning problems, you can use H2O. So you can see that this is our growing customer base in different industries. So mainly, we start with financial sector because they are the guys who want to get the cutting edge technology first, and that's why we have a bit more customers in that sector. But then you can also see that we have other customers in different industries. So you may ask, how do we make money from open source software? So because some of them they need support, they need enterprise support from open source software. So that's why they pay us. They become our customers, and then we provide them with enterprise support on both open source and commercial softwares. Okay, just a few more slides from marketing. So we have a lot of companies using H2O now. So we have more than 10,000 companies using H2O, and then we have many people, data scientists using H2O worldwide. And then we have the next chart here is more about the famous Magic Quadrant from Gartner. So we are one of the leaders in the Magic Quadrant for data science and machine learning platform. This is based on the customer feedback and other functionalities in the software. So we are happy to be recognized as one of the leaders, as well as IBM there as well. And we partner with many different companies. So IBM is one of our strategic partners. So we work with IBM closely to make sure that Driverless AI runs quickly on Power system. So this is one of the focus of the talk. So we try to emphasize why we should use this software with IBM Power. Just a quick view of all the platforms that we provide, all the products that we have. So those on the left-hand side, I don't know why I keep going back. So those on the left-hand side with the white background, they're our open source product. So what it means that they are all with Apache 2 license, so you can put them into your software without doing open source itself. So you can actually sell H2O inside your software. But please don't do that. Okay. So we have H2O, the open source platform that we've been like a mature, and stable platform that we've been working on for years. And then we integrated with Spark. So we have the sparkling water platform like products to have machine learning ability on Spark clusters. And lately, we try to port our algorithm from CPU, from H2O core CPU-based to GPU-based. That's why we're trying to use the GPU and IBM Power. So this is H2O for GPU package on GitHub. So they are all open source. But what we learned from the customer feedback, what we learned from all the years of working with customers, is that we want to create a few more functionality, including automatic feature engineering, auto-report, explanation of the model result, and all this. So we package all these things into this software that on the right that is Driverless AI. So why do we want to create this software for our users? So this is one of the reasons why we want to do it. This is a simple diagram to show you the workflow, like a typical workflow for enterprise and machine learning. Not every single detail step is in this diagram, but you can kind of understand. You start from data integrations, so you have different data source, different tables from different places. You want to integrate them to make the first table, to create the first table for machine learning, which you have features and a target. Then you have other things to do. So you have to check the quality of the data. You have to transform some of the features, some of the numbers or other categorical values in the data. You want to create some more features. You want to do some feature engineering. And then you do the modeling. So you have to tune, maybe you have to try different algorithms because you don't know which one are the best for a new data set. You want to tune it because you want to optimize which algorithm for a data set that you put in into the system. Then you have the model. And you also want to export the model to deployment, right? And after that, you also want to explain the model maybe to your customer, maybe to your colleague or your boss. So what we have here, this software, Driverless AI, is a simple software here to automate most of the tasks in the second half of the pipeline that I saw here. So from the point that you have your own table, your first table, and Driverless AI can take care of most of the tasks in the rest of the pipeline. So let me point you to one of our H2O colleagues. So this is Professor Leland Wilkinson. So he is like the godfather of data analytics and data visualizations. So he's the author of the Grammar of Graphics. So it was like a very popular book that inspired Henry Wickham in our communities to create a ggplot2 package. So he's now working on this automatic visualizations in H2O. So what that means is that we don't need the users to specify what kind of graph that we want to create for some quick insight. So we just ask them to fit in the data. And then once we have the data, we will use different algorithms to detect the interesting patterns in the data set. So we don't show every possible combination of graph to the users. We only show them the interesting graph. So this will save the user time to do some exponential or exploratory data analysis before they want to do machine learning. And then I want to point out to my other colleagues that like the Kaggle Grandmasters. So do people know about Kaggle? It's a data mining competitions platform that you compete with each other worldwide to tackle really difficult machine learning problems. So we have some of the best in the world working at H2O. So this is me here. I'm trying to catch up with them when I have time, but I'm not as good as them. But we have the very best in the world to work on this platform. So what we try to do is to translate all our knowledge in data science, in machine learning, into some what we call the recipes in feature engineering. So we try to create some new features based on the raw features. So for example, you can have interactions between two features. It could be the feature A plus feature B, and then we can have other more fancy, more hardcore feature engineering tricks that we use only in Kaggle. But sometimes it's a neighbor's task to test different feature engineering tricks one by one. So what we're trying to do is to automate all this testing for the users using GPU to accelerate the process for the users, so they don't have to try this trick manually, and try to rewrite the code every time they need to tackle a new data set. And then also we try to capture what they know about tuning and stacking of the model. So we try to figure out when you have a new data set, when you have all the new features, how will you build models to get the best performance from the data set. So this is all based on years of experience from different Kaggle competitions and the data science project in the past. And we do, so some people will ask what kind of algorithm we have. So we have maybe we call it old school or traditional algorithm, like tree-based algorithm, like XGBoost or gradient boosting machines, random forest, etc. And we also have the new stuff. So we use TensorFlow at backend to provide deep learning capabilities in Driverless AI. So we combine both. So we can do both in Driverless AI, depending on the problems that we have to solve. So the next question that we want to ask is how well will this do in the real world settings? So we try to use Kaggle again as a benchmark. So this is also will be the live demo that I will show you in a minute. So we use some of the competitions in the past to try to use Driverless AI to create the solutions automatically in 2 hours, and try to compare the work with some of the best team in the past, which they would spend 2 or 3 more months on one single problems. So we say that we can achieve some kind of similar performance in 2 hours, comparing with the work that the people did for months in the past. So this is a good sign that we can use this for the business, because when you have new data sets come in, you don't want to spend months to get to good answers. So now you can do it in hours or even minutes, depending on the problem size. And we also have, that's not the end, so we also want to provide some kind of explanation to the users. So for example, if you have a machine learning model from Java's AI, sometimes it's hard to explain the complexity or the black box model to the end, to the result, to the customers. So maybe for GDPR, you may want to explain your model. So this is some functionality that you can use it to explain your model. But this is not the focus of the talk. But you can find out more information later on from some video links in the presentations after this talk. But I want to focus on this today because I want to show you how you can create this pipeline from doing a simple experiment using Java's AI. So from training the model, from doing feature engineering, from doing different model tuning and stacking. So once you have the final model, how do you put it into a pipeline that you can give it to the downstream, to give it to the deployment team, to embed into different applications? And that is the focus of this talk. So how we can automate this quickly. So why? Because if you think about different steps here, in reality, they may involve different teams. So there may be a team looking at the data quality, the transformations. There'll be another team looking at the feature engineering, and then another team on modeling and stuff. So from one team to the other, there may be some frictions or some kind of other incompatibility of the code. So maybe some people using Java, some people using Python, some people using R. So that is something that we try to avoid in these situations. You have to try to automate the pipeline seamlessly. So when they have the data in, we have the model out, and then we have the pipeline as well to come with that model. So that will, again, beneficial to the organizations because you don't spend that much time to deal with the frictions between different teams. Is that okay so far? Right. So next thing I want to do is a quick live demo. So this is again based on the benchmark I showed you earlier is from a bank or BNP. Based on one of the problems they have is about the claims management in the bank. So what we want to do is a binary classification. So they have different customers coming in. They have different claims of maybe other insurance or other stuff. So we want to separate them into two different types. So the first type is some claims that looks okay, look legitimate. So that should be approved quickly without further interaction from the human. And the second type is that this claim may look a bit, say, dodgy, or maybe they require a bit more attention from the expert human users. So this, we want to separate them into two types of claims based on different features like this. So this is like the first few features that you can see. So we have the target, which is either 1 or 0. It's a binary classification. Oh, sorry. It keeps coming back. I don't know why. And then we have about 131 features on the right-hand side. So they could be numerical, they could be missing, they could be like a categorical, like C or A, something like that. So the data size is about 113,000 samples and about 131 features in the data set. So it's a medium-sized data. Okay. So what I'm going to do next is to show you the actual demo, how to use, say, from data that I got from these cargo accommodations, put it into Java's AI, run the model, and then get the result, and try to deploy it in a simple way. Okay, let me just cancel this and go back to my browser. Okay. Sorry, is there a question? Okay. Okay, that's full screen. Can you see it, or is it too bright? Okay, is it possible to turn down a bit of the night? Thank you. Okay, perfect. Is it okay for everyone now? Yeah, you can see it now. So first you can see this, I already imported the data. So again, this is a simple demo, so they have only 2 CSV. But you can add data sets from different sources. You can use anything on local system. You can upload the file. You can use Hadoop. You can use SV, and then later on we will Spark as well. So this is different ways to import the data set, but I'm not going to show it today. So this is now based on a simple CSV. So we have 2. So the first one is for training the model, and then the second one is for testing. So some new data set that we don't have the answer, but we want to use the features to get some predictions. Okay, so what do we do as a data scientist when you have a new data set? You want to have a look first. You want to do some eyeballing before you do the machine learning models. So we have 3 options here. The first one is a very simple histogram that just show you some of the statistics of different features. So you can see target is like a 0 or 1. There are fewer 0 than 1. So these are the ones that the 0 are the ones that came that require more attentions by the human. And the 1 is the one that are okay to just be approved quickly. And then you can also see the other features. So some of them, they are numerical. You can see a histogram. Some of them, they are categorical. You can see either is a C or none. So there are different kind of features in this data set that you can just go through quickly. So nothing too fancy right here. I just give you a quick summary, a handy function to show you some interesting statistics. So the next one is the one from Professor Leland Wilkinson, which is what we call the smart or automatic visualizations. So if I choose that, so this is like the way that we try to use different algorithms to detect interesting patterns in the data set. So we're not going to show you all different combinations that we can create from the data set. We just want to highlight the most interesting one. So for example, sometimes I will just look at the outliers and see whether there's some like some outliers that I may want to remove them before before I create the machine learning model. So you can go for different features, you can go for different outliers. So if you are interested in going into to look into the actual record, you can just go to the orange point, click on it, and then it will bring you to the actual record. So we have, say, 3 samples in here that we think they could be outliers. So the user can make the decision on how they want to deal with these outliers. And also, if you want to find out more, you can also click on Help, and then it will bring you to the actual reference to the algorithm that you use. So this is, again, a paper written by Professor Wilkinson back in 1999. So he wrote a lot of different papers on different visualizations trick to help users find out the most interesting patterns in the data. So that is one of the function here that allows people to get some quick insight without doing the plot themselves. Okay, so let's say at this point, we're happy with the insight, the first insight. Then now we are trying to build the actual model. So I'm going back to the actual data, and then next time I'm going to choose the last option, predict. So if this is the first time that you use this software, they will ask you whether you would like a tour. But today you have me, so I'll do it for you today. So not out. So this software is only used for supervised learning. So we need to supply, the first thing is the target of what you want to predict in this problem. So we can choose the column. So again, this is named conventionally a target. So we choose that. So we figure out some other information. So you know that is a unique, there are 2 unique values. So it's a binary classifications. So we will automatically show you the actual feasible metrics to measure the performance. So if you have the test data set like for cargo, so you can also supply that. This is not used for creating the model. This is only used for making some predictions at the end. But you can also do that after this experiment, so you don't have to supply it right now. And then I want to bring you to the 3 numbers here. So I may not be able to go through some details, but saying that we're trying to simplify some of the thinking of machine learning into 3 numbers. So the first 2 are quite easy to understand. So how accurate that you want it to be. So for example, if you turn to 1, then you have a simple model, but they may not be accurate enough for real. But you get some quick, like a quick model to have some feeling of the data set before you do the real thing. So this is like, again, if you turn to the other way, to 10, then we try to use all the complex, all the cargo tricks, all the things that to squeeze the best out of the data from different tricks. But that's a trade-off between this accuracy and the time that we need to spend on the experiment. So a simple trade-off between the accuracy and time here for the user to consider. The next thing again is again easier to understand is the time. So how many iterations that you want to run. So for example, today I want to do a quick live demo. So just use one, which just go for a few iterations and then stop. Then of course, in the real world, if you have enough time in the world, then you can spend a few hours or more. So you can put it to 10. Then we just try to do as many as possible until there's no improvement in the data set. Then we'll just do early stopping. So let's do one today, just for a quick demo. And 25. And the last thing is how about the complexity of the model. So for example, if you want to interpret the model better, say I want to put it to 10, that means that we try to force the experiment to use some simple like linear model to work on the problems. So that in that case, the accuracy may not be the best, but it's easier to explain afterwards. So it's maybe this useful for insurance, for bank, for other sector that they concern more about the explainability than the actual accuracy. On the other hand, of course, if you don't care about that explanation, you just want to squeeze the best accuracy, then you can turn it back to 5, etc. So you can find out more settings in the documentation site. I will show you later on. So the next one I want to show is the expert setting here. So this is like we have more control of the different things. So for example, you can choose different algorithm that we use in this experiment. You can turn on TensorFlow on and off. You can turn on IBM, etc. So we try to give make it easier for the users to choose different kind of algorithm in the data set, so that they can have more control of the algorithm that they want to use. But of course, if you don't want to look at into this will be automatic. So we will choose the best for the users automatically in the backend. Okay, so that is like some of the key function I want to show you in this interface. So when I click on this button here, when I launch this experiment, it will start working on it on GPU. So let's give it a bit time to warm up. So you can see that quite a few things happening at the same time. So let me just try to explain it to you one by one. So you can see on the first thing that you notice there's a notification saying that, okay, there's a column called ID. So usually this ID column is not meaningful for predictions because they're just an ID, like a random numbers associated to the record. They have nothing to do with the target itself. So try to avoid some human or newbie errors. We try to remove that for the users if we detect something like this. So that's one of the things that we try to avoid human errors. And then you can see it start working on some GPU. So we have 8 GPUs on these machines for my workplace. So we're trying to use different resource on the machine. So CPU, memory, and GPU. We try to use it efficiently to work on the problem on distributed fashions. Because what we try to do is to try different things, try different settings, try different feature engineering tricks, and try to use a model to evaluate the performance of different tricks. So at some point you will see on the graph here, you will see the evaluations of the metric. So here it is. So you can see that first of all, you can see. Let me go here. So we're trying to use log loss here in this case to measure the performance of different feature engineering tricks. So this case, lower is better. So we try to make it lower and lower every time. So the first iteration here, iteration 0 here, what we try to do is try 4 random models, so 4 random tricks, 4 random feature engineering sets. But because we don't know which one are the best, which ones are the best settings for this new data set, so we try to use genetic algorithm in approach to optimize the feature space from time to time. So let's say we have 4 models here. Each of them, they have slightly different feature engineering tricks. So when we try to look at this, this is the best model coming out from the first iterations. So what we try to do is to use this information from here. So this is the best model here, the best feature engineering set here. We try to evolve that with genetic algorithm to the next iteration. So at some point, you will see that in the next iterations, we try to evolve from the best point from the previous one and try to get better at the next iterations. Is that okay so far? Does it make sense? Okay. Okay. Is there a question? Oh, great. Thank you. Yeah. So I want to mention that this is well, the fancy interface that you can use on the web, but that's a Python backend. So if you want to do it in a script, in Python script, in Jupyter and other IDE, you can do it, the whole thing in that scripting language. So you don't have to click and think about how to do click everything in order to automate the process. You can do Python as well. Okay, so the next, again, now you can see that now we have the second iteration, iteration 1. So we try to evolve from the previous best to here. So this is now the best of the second iterations, iteration 1. And then you can also see that when I change from here to here, that feature importance change. That's because now we are looking at a different set of feature transformation or feature engineering tricks based on the cargo grandmaster knowledge. So this is like we put the cargo grandmaster into the box, into the machines, and ask them to look at this data set repeatedly using different tricks to try to squeeze the best out of this data. And these are something like we try to do the feature engineering on different features. So later on, I'll show you the report that you saw all the steps that we have to transform the features from raw features to the new features. So these are most of the tricks that we don't normally use to test the data like in a manual fashions. But if you can do it with GPU accelerations and in an automatic way in the software, then it is the most efficient way to squeeze the best out of the data in a short time. Because if you have to do this like in the manual fashions, you may have to spend weeks or maybe months to just do this for one data set. It's quite laborious process to test it and run it again. So what we're trying to do now is just to wait for it to finish. But let me just show you one that I did before. So just already made experiments that I did before. So it should be like this when it's finished. So what we're trying to do is like, again, you can see that there's an improvement of not loss across time. At the end, this is like the final point that we will use this as the base of all the feature engineering tricks. So we use that to build the final feature set, and then we build the ensemble using that features, the new features. And what we can do after that is that you can do a few things. So you can, let me show you quickly. You can interpret this model. You can make some new predictions on a new data set. You can transform the raw features into new features if you want to. If you want to build the build models based on new features, you can do that. There also, you can do the pipeline, so you can download the pipeline which I'll show you later on for the actual deployment. If you want to capture the whole thing and put it into a pipeline for productions. And you can also download a summary. So let me just, let me see the time. Let me just quickly show you what's it like in deployment. So let's say I have finished experiments. I can download the pipeline, and it should look like something like this. Let me show you. Okay. So just a few files from that zip file. So, but maybe it's clear if I show you this. Okay. So what you see here is just we have some files from that zip file. So the pipelines, what we call the module 2. These are the files that is a pipeline that include both the feature engineering and the actual the models itself and the scoring mechanisms in one single like in those files. And we also have to supply the feature, the license, because we have to use a wide license to make the scoring happen. So what I need to do is to, this time I want to score a simple CSV. So example CSV is like some 10 examples in a set with only the features, the raw features, same as the inputs that we use for the experiment. And what we do now is that you can see the command line. So we supply the whole thing. This time we're just taking CSV as an input and then putting it out to the screen. But you can change that to modify that input and output patterns to embed this into your software for different applications. But this is just showing you an example that you can just capture the whole thing for all the feature engineering, for all the scoring pattern into that module, that pipeline, and then you can just use that to spit out the number. So these are the outcome from the prediction. So we have the features. They go through the transformation to become new features, and then we use a model to make predictions, and these are the predictions. So it's a probability between 0 and 1. And then each of them, and then if you score in real time, then for each row is about 3.1 milliseconds in real time. So it's fast enough to be practical to be used in the real world. Okay. Can you see it? Yeah, I just want to show you. So this is like if you don't want to use the interface from the web interface, you can also use Python as a backend to interact with that Driverless AI. So maybe it's not so clear on the screen, but okay. So then finally, I want to quickly mention that. So why we have this talk today? Because Driverless AI works on Power, IBM Power. You can go to our website and you can find out how to install Driverless AI with different packages. So it could be DEB, the Debian package, could be IBM, could be a Docker image. So that are all information that you need from this website. It's docs.h2o.ai. So you can find out more from there, and you can also see other webinars that we did in the past to give you a full flavor of the software. And the other thing that I can also send you later on, if you're interested, is the use case that we have with PayPal, because PayPal, they have the IBM Power machine and Driverless AI as a software to power the fault detections at PayPal. Also, because we have some figures saying that if you use AI on Power, you can actually get better performance than your competitor, like the company N, right? So it's free to try, so everyone can try it. So you can just go to our website, use your email, sign up for a free license for 21 days. So of course, if you want to extend a license to try a bit longer, we can also do that individually to you. But this is like you can try it for free before you trust the software and get it. Thank you again for having me today. Thank you.